Let's get started on climate change number 4. The topic today is emissions. Climate change number 4. Basically, in the 1800s, people first started to get worried that the coal that they were burning for the Industrial Revolution was going to change the planet. This is mostly in the form of soot, but people were starting to think about this. Then World War II came with significant science and technology advancements for good and for ill. Now, nuclear bombs really led to this concern that we were doing big enough things that we could actually be changing our atmosphere, which led to a lot of this climatology science that we're getting into today. So climate change number 4, we're going to put this as a big heading as emissions. I don't know why I put it in quotations just now. That is what it is. We are doing emissions. You could put quotations, you could put stars, you could put double underline. Anyways, we're talking about emissions. We're talking about the anthropogenic additions to our climate of greenhouse gases that we have produced by making electricity, by making heat, by doing transportation, by doing agriculture, by doing industry, by doing construction. Agriculture, construction, industry counts as well. Of course, industry also is electricity. Ultimately, our current society is producing 59 plus or minus 7, so there is some uncertainty in this number, but we're going to say 59 gigatons per year of greenhouse gases. That's the big number. For an exam purpose, you're going to memorize that number. We're not going to memorize a lot of numbers this semester, but we are going to remember 59 plus or minus, or 59 gigatons per year. You don't need to memorize the plus or minus 7. This number comes from 2019, so it is 5 years out of date. Now, in the course of human history, or at least since the Industrial Revolution, the cumulative sum is 2,400 gigatons. And the question, I guess scientists and we in society are asking is, how much more can we offer before there's some change that's a problem? If we're at 2,400 now, can we get to 3,000? Can we get to 5,000 cumulative greenhouse gases? When will the Earth start to tip in a way that is bad for us? This number of 59, or this number of 2,400, is all gases across all of these sectors. Now, who's number 1? If we want to break this out geographically, this isn't science here, but maybe it's human interest. In my class, I have people from all over the world, and you know what, listening on the internet, watching this video, I bet I have people from all over the world too. So who's number 1? Currently, it is countries in Eastern Asia. These are countries like China, Indonesia, oh boy, forgive me if I spell your country wrong, right? All right, China, Indonesia, Vietnam. These are not necessarily developing nations, but these are nations that their economies are just booming. And who's to blame them? Right? Who's to blame them for using a lot of times fossil fuels to build an economy for the betterment of their people? Now, here's North America, this is the United States and Canada. We're currently at 12% of emissions, but go backwards in time and look at what percent we make up. And in fact, if you look at the historical leader for the sum, you know who's number 1? USA. USA. We're the sum leader. And that's part of the reason why we're an economic force we are today. Europe is second. But one of the things that's interesting for North America and for Europe is the actual number that we're doing today is less. So like, see how Europe is now at 8%, but it used to be 16%? Europe has started to do processes that have reduced their amount of emissions, right? Okay, one other thing I want to talk about before we get into the meat of this lecture is something I see on the internet that is called misinformation. And I want you to, with me, draw a volcano. And from this volcano, there's going to be a plume of ash rising to the sky. Because what I'm seeing a lot is people making claims that volcanoes wipe out human emissions, and that is not true. In fact, the global average for greenhouse gas emissions from a volcano is 0.2 gigatons per year. This is the equivalent of 3 days worth of anthropogenic. Now, that's going to, if there's a huge eruption, of course that's going to change. This is just the annual average. So I want you to know, and know beyond a shadow of a doubt, this is because I'm a volcanologist, that anthropogenic greenhouse gas emissions far outpace the natural production from volcanoes. What we're going to do today is I want to talk about the three. All right, we're going to go now through the three sources. So this is going to be a heading here. 3 sources of anthropogenic emissions. Three sources of anthropogenic emissions. 1, 2, 3, and then this lecture is going to be done. The number one, the most important source of greenhouse gas emissions, you can guess it, you've heard about it before. This is the burning of fossil fuels. Burning fossil fuels. I want to define what a fossil fuel is. It's a great name, actually, because it's a fuel that provides energy. And in fact, we're going to say this here. This equals, I want you to just have this as equal to energy. And it's not transportation energy. This is like electrical energy. So what a fossil fuel is a carbon that is trapped in a rock. That's what I have you learn. Carbon trapped in rock. This carbon used to be alive, but now it is fossilized. We often call these, maybe more technically, we call them hydrocarbons. This might be a word you've heard before. Hydrocarbon is synonymous with a fossil fuel, and the reason for this is a hydrocarbon is a chain of carbons that is bonded to hydrogens. So this is how you'd like chemically, structurally, I gotta put all these H's in, I put too many C's because now I have to put too many H's. All right, this is what I mean by a hydrocarbon. All right, so we're burning fossil fuels for energy. This equates to 65% of all emissions. So maybe I don't need you to memorize 65%, but I would like you to know that most of all emissions is from the burning of fossil fuels for energy. We could show this in a picture here. So here is a shale, and what this shale has inside of it are a bunch of fern fossils. Can you see those ferns? Of course you can see the ferns. I don't need to point out the ferns. But this is actually from Antarctica, and this is a shale that trapped the carbon from these fern plants that used to live 200 million years ago, and now the black is, we could scrape it up and actually burn it. This is not economically valuable, it's not a coal deposit, but it is a hydrocarbon that could be burned and can be used to provide energy. Now, one thing I do want to say is I'm teaching at UT Austin, and so that means I am in the state of Texas. Now, the state of Texas is associated with oil and natural gas. You ask someone, what is geology? I could ask my wife, what is geology? Because she's a Texan, and she would tell me it's oil, it's natural gas. And in the past, this has been associated with money, and that's absolutely true. Texas makes something like $4 billion per year in revenue because of its oil and natural gas. It supports 100,000 to 300,000 employees working in this we call maybe petroleum industry. But in recent years, because of climate change, this idea has really become very negative, and it's put a lot of political and economic pressure on Texas and all sorts of other places that are producing oil. Nobody wants to be associated with something negative or something bad, and so there is a rebellion, right? If you think about what does a Texas think about climate change, you might hear like this answer: no, that's like made up, etc. Right? Because they don't want to be associated with something bad. I guess I'm sorry about that. There are bad things about this oil industry, but there's good things as well. There's neutral things. For one, I'm in a department that's called the Department of Earth and Planetary Sciences, but it used to be called the Geology Department, except for nobody wants to be called the Geology Department anymore because it's so with oil and natural gas so intimately. Anyways, that is a rabbit trail. I'm not supposed to put rabbit trails in my online videos. Those are only supposed to be for in the classroom, but I wanted to elaborate on that briefly. Okay, the second source of emissions is transportation. And the caveat here, or the other thing to kind of put in a whisper or in a smaller text, it's transportation by burning fossil fuels. This ends up being about 15% of total emissions. And if you wanted to, there's no reason why you can't add this 15% with this 65% and add them together and say 80% of all emissions is the burning of fossil fuel. It just ends up being that most people break these two things apart. Most of this is road transportation. Let's see if I have a figure for that. I think this is my figure. Yeah, indeed it is. All right, let's find a graph. This is from 2023 showing the breakdown of transportation emissions. If we go to the very top here, so that says, what is it, 8.9? So 9 gigatons per year across our planet is produced by the burning of fossil fuels for transportation industry. And here's the key. Most of that is road. You see that? What's cool is we can buy EVs and we can buy hybrids and actually reduce that dependence. Maybe another number that's interesting to hear would be the sum of aviation, all right, airplane travel. This ends up being, okay, what's that? Gray plus red, that's about 11% of the 9%. So what is that? 11% of 9%, that's like 1 gigaton per year. And that ends up increasing. And I can't blame people. Flying is a fast way to travel. All right, and the third source of emissions is agriculture, or maybe we should call it the land use sector. So number 3 is land use sector. This one's kind of a weird one. It's going to be 20% of our emissions, and it's the removal of a sink much more than it actually is an emission. But in fact, why don't we say this? A lot of land use sector is removal of sink, and I don't know why people necessarily calculate it this way, but if they've decided to, perhaps it's fair. Think about it. It's removal of a sink because in many ways this is deforestation. It's really important in developing nations, in nations with large forests and jungles that have no other way to make energy. They're going to cut down those forests for their energy. The other aspect of the land use sector besides deforestation is cattle ranching. If you want to add sheep or goats, you can. It's livestock ranching more than anything else. And cattle ranching produces methane. So all these others have been mostly CO2 as the gas of emission, but cattle ranching is CH4, and it is 3 gigatons, which is kind of wild because airplanes, if you remember, that was just 1 gigaton. So cattle ranching, livestock, really does put out a lot of greenhouse gas emissions. Well, there you have it. Next lecture, we're going to move on to the sinks. Where do these emissions go?